Good day, everyone.
So here's the objectives on our report. In normal distribution, you can understand the bell-shaped curve where data clusters around the mean, with examples like heights or test scores illustrating its importance. In normal distribution curves, you can learn about the symmetrical, bell-shaped nature of these curves and how the mean and standard deviation shape them. In properties of normal distribution, you can explore the 68, 95, and 99.7 rule, providing insights into data spread within different standard deviation from the mean. In standard normal distribution, you can discover the special case with a mean of 0 and standard deviation of 1, crucial statistical analysis. In z-score, you can understand this standardized measure indicating a data point's position relative to the mean, facilitating data comparison. In z-table and how to use it, you can learn the purpose of z-table and finding probabilities associated with specific z-scores, aiding statistical calculations. In finding areas under the standard normal distribution curve, you can explore techniques to calculate probabilities within specific value ranges, offering insights into event likelihoods. In a normal distribution curve as a probability distribution curve, you can understand on how this curve is used to calculate probabilities and make statistical inferences based on known parameters.
Normal distribution. In statistics, a normal distribution of Gaussian distribution is a type of continuous probability distribution for a real-valued random variable. The general form, its probability density function. As you can see, the normal distribution formula is fx is equals to 1 over standard deviation square root of 2 pi e. The mean of x is the mu, standard deviation of x, and the pi is 3.14, and the e is 2.71 or 72.
So, the normal distribution has the shape of a bell curve. It looks something like this. Now, the notation for it is this. Random variable x. So, for normal distribution, you have two important parameters you need to know. The mean and the standard deviation. Now, the mean is right in the middle of the bell curve here. And here, this would be one standard deviation from the mean. And here this would be about one standard deviation away from the mean on the left side. The z-score that corresponds to one standard deviation is simply 1. When x is less than the mean, the z-score is negative. So, 2 standard deviation away from the mean, z is equal to 2. On the left side, z is gonna be negative 2. And here is 3 standard deviation from the mean. So z is gonna be 3. Same on the other side. Z is negative 3. Now, the formula that we need in order to calculate this z-score is this. Z is equal to x minus the mean divided by the standard deviation. But sometimes you may need to calculate the x. So this is the formula. X is equal to the mean plus z times the standard deviation. So, mao ni ang mga formula nga dapat nimo i-take note.
Data can be distributed in different ways. It can be spread out more on the left or on the right, or it can be jumbled up. But there are many cases where the data tends to be around a central value with no bias left or right, and it gets close to a normal distribution like this. The blue curve is a normal distribution. The yellow, which is the histogram, shows some data that follows it closely. but not perfectly, which is usual. It is often called a bell curve because it looks like a bell. Many things closely follow a normal distribution, like heights of people, size of things reduced by machine, errors in measurements, blood pressure, marks on a test. We say the data is normally distributed. The normal distribution has mean equals median equals mode. Symmetry about the center. 50% of values less than the mean and 50% greater than the mean.
Parameters of normal distribution. Mean. The mean is used by researchers as a measure of the central tendency. It can be used to describe the distribution of variables measured as a ratio or intervals. In a normal distribution graph, the mean defines the location of the peak and the most of the data points are clustered around the mean. Any changes in the value of the mean move the curve either to the left and right along the x-axis. Standard deviation. The standard deviation measured the dispersion of the data points relative to the mean. It determines how far away from the mean the data points are positioned and represents the distance between the mean and the observation.
Properties of normal distribution. The first one is the symmetric. The mean, median, and mode are equal. Empirical rule, skewness, and kurtosis. It is symmetric. A normal distribution comes with a perfectly symmetrical shape. This means that the distribution curve can be divided in the middle to produce two equal halves. The symmetric shape occurs when one half of the observation falls on each side of the curve. This symmetry indicates that the probabilities of observing values to the left or right of the mean are equal. The mean, median, and mode are equal. The middle point of a normal distribution is the point with the maximum frequency, which means that it possesses the most observation of the variable. The midpoint is also the point where these three measures fall. The measures are usually equal in a perfectly normal distribution. So, for example, if you have a normal distribution with a mean of 50, the median will also be 50. Empirical rule. The empirical rule, or the 68, 95, 99.7 rule, tells you where most of the values lie in a normal distribution. Around 68% of values are within one standard deviation of the mean. Around 85% of values are within two standard deviations of the mean. Around 99.7% of values are within three standard deviations of the mean. The empirical rule is a quick way to get an overview of your data and check for any outliers or extreme values that don't follow this pattern. Skewness and kurtosis. Skewness and kurtosis are coefficients that measures how different a distribution is from a normal distribution. Skewness measures the symmetry of a normal distribution, while kurtosis measures the thickness of the tail ends relative to the tails of a normal distribution.
The empirical rule, or the 68, 95, 99.7 rule. So the empirical rule tells us that 68% of the x values are within one standard deviation of the mean. 95% of the x values are within two standard deviation of the mean. And 99.7% of the x values are within three standard deviation of the mean. So knowing that, how would you calculate the area under the curve expresses percentage in each of these sections? Well, kung kani diri nga part is 68% and if we divide it by 2, this region must be 34%. Now, what is the area during a part So to get the answer, we need to subtract 95 and 68. So 95 minus 68 is 27. Then divide it by 2, we got 13.5. Now, what is the probability of finding the x values in these regions? So we need to subtract 99.7 and 95. So 99.7 minus 95 is 4.7 and divided by 2, so we got 2.35%. So that's the probability of the x values in that region. Now, the remaining portion. So, to find the remaining portion, we need to subtract 100% and 99.7%. 100% because the area under the curve is 1 or 100%. So, 100 minus 99.7 is zero point 0.3. Then divide it by 2. So, this 0.15%. So 0.15% chance of finding or getting the x value beyond 3 standard deviations. So these are the values we use the empirical rule to solve the questions relating to the normal distribution. So take note of this information because it will be useful.
Standard normal distribution. The standard normal distribution, also called Z distribution, is a special normal distribution where the mean is 0 and the standard deviation is 1.
Z-score. A z-score is a standard score that tells you how many standard deviation away from the mean an individual value x lies. A positive z-score means that your x value is greater than the mean. A negative z-score means that your x value is less than the mean. A z-score of z or 0 means that your x value is equal to the mean. How to calculate z-score? To standardize a value from a normal distribution, convert the individual value into a z-score.
So here's an example in finding a z-score. You collect SET scores from students in a new test preparation course. The data follows a normal distribution with a mean score of 1,150 and a standard deviation of 150. You want to find the probability that SET scores in your sample exceed 1,380. So to standardize your data, you first find the z-score for 1,380. The z-score tells you how many standard deviations away 1,380 is from the mean. So step 1, subtract the mean from the x value. So the x value is 1,380, then the mean is 1,150. 1,380 minus 1,150 is 230. So step 2 is divide the difference by the standard deviation. The standard deviation is 150, then the difference is 230. So 230 divided by 150 is 1.53. Therefore, the z-score for a value of 1,380 is 1.53. That means 1,380 is 1.53 standard deviation from the mean of your distribution.
Use the standard normal distribution to find probability. So the standard normal distribution is a probability distribution. So the area under the curve between 2 points tells you the probability of variables taking on a range of values. The total area under the curve is 1 or 100%. Every z-score has an associated p-value that tells you the probability of all values below or above the z-score occurring. This is the area under the curve left or right of that z-score. So let's proceed into z-test and p-values. The z-score is the test statistic used in a z-test. The z-test is used to compare the means of two groups or to compare the mean of a group to a set value. Its null hypothesis typically assumes no difference between groups. The area under the curve to the right of a z-score is the p-value, and it's the likelihood of your observation occurring if the null hypothesis is true. Usually, a p-value of 0.05 or less means that your results are unlikely to have arisen by chance. It indicates a statistically significant effect. By converting a value in a normal distribution into a z-score, you can easily find the p-value for a z-test.
A z-score table. It is also called the standard normal table or z-score chart. It is a mathematical table that allows us to know the percentage of values below, usually a decimal figure, to the left of a given z-score on a standard normal distribution. So there are two z-score tables, which are the positive and the negative z-score tables. So positive z-score table. It is used when the z-score is positive and above the mean. A positive z-score tables allows you to find the percentage or probability of all values occurring below a given positive z-score in a standard normal distribution. Negative z-score table. It is used when the z-score is negative and below the mean. A negative z-score tables allows you to find the percentage or probability of all values occurring below a given negative z-score in a standard normal distribution. So here's how we can read it. First, look at the z-table. The left column will contain the first part of the z-score. Example, the whole number in the first digit after the decimal point. Then go down this column until you find your z-score's first part. Next, look at the top row of the z-table. This row will contain the second part of the z-score, the remaining decimal number. Then go across this row until you find your z-score's second part. At last, the intersection of the row from the first part and the column from the second part will give you the value associated with your z-score. This value represents the proportion of the dataset that lies below the value corresponding to your z-score in the standard normal distribution.
Example, using the z-distribution to find probability. We've calculated that a SAT score of 1380 has a z-score of 1.53. Using the full z-table, we find that for a z-score of 1.53, the p-value is 0.937. This is the probability of SAT scores being 1380 or less, like 93.7%, and it's the area under the curve left of the shaded area. To find the shaded area, you take away 0.937 from 1, which is the total area under the curve. Probability of x is greater than 1380 is equal to 1 minus 0.937 and 0.63. That means it's likely that only 6.3% of such scores in your sample exceeds 1380.
This part is for our classmates. So for your participation to our reporting about the normal distribution and the standard normal distribution, we want you to please answer these two example problem and just comment your answers in the comment section. Thanks.